Did y'all like the pep rally today?
It was fun.
Not exactly a glowing review. Man.
That is good news.
Why would you get that at?
It was emailed to me from Dr. Hudson.
Did you propose it?
I did. That's why I got it.
I mean, I don't see why they.
I'm going to add it to kids' course requests.
So now it has to be added to the CAP. Is there not a due date on when the CAP is supposed to be finalized?
I don't know the answer to that. I know Mark sent an email out. Not every class has to be in the CAP book. Huh? I don't think. Intervention classes, I don't know.
Okay,
I'll find out.
Okay, thanks for letting me know.
Yeah.
Samantha.
Yesterday was this month. You're such a bad friend.
Did you get the piece of
No, I saw those texts from Art. I did not.
What's that? Or is it asking for the range?
They're in babies.
How is cheese so slow going down? You just factor this out. Don't worry.
Can I give you your, or is that the,
All right. To start off today, we're going to look at number 56. 56 was the practice FR2s from last class. And we did both of those on the back page together. And I'd asked you to do one of them on the front page. I'm not asking you to turn it in yet. I'm asking you to finish it first.
Oh, I thought it was due at 11:35 today.
That would have been something else. I don't know what you're thinking of. Not that one. Because we're about to do one more from that, and then I'm going to ask you to do the last one too. That's part of the day plan.
I'm pretty sure he posted that. That's just like a something. I just turned in the survey.
All right, so you should have the back page finished, and you should have stuck with one of the three on the front, which means you should have two of these or less to do. So to start off class today, we're going to go over one as a group, and and I will ask you to do the last one as well today during class before I ask you to turn that in. But on the front here, some of you may have done FRQ1, some may have done FRQ2, and some of you may have done FRQ3. So the one that we are going to go over, okay guys, y'all need to be settled in by now. The bell rang several minutes ago. If it's something important you need to ask, then ask me, because other people need to hear it too. And if it only pertains to you, then you need to wait. So, which one of these from the front you guys want to do as a group is completely up to you. I have no preference. I have my own opinion on which one I think is the hardest of the three. I think you probably should have skimmed all of them before you decided which one you wanted to do last time though, so maybe that has some input. So, does anyone have a preference whether we do FRQ 1, 2, or 3? Number 1. Okay. He was first one ready, so he got the pick. Now, if you already did FRQ1, that's the one that you did. While you wait, you should do one of the other ones, especially if you've checked your answers and such. I guess maybe if you did FRQ1 and you finished it and you feel good about it, but you think it might be more efficient, then I guess you can follow along. But I am going to ask you to finish up the rest of these and turn them in. So, okay, so number 1, find the critical numbers of G. Well, how do we find critical numbers? Where do those come from? One more time. First derivative what? Zero or undefined. Okay, so to take this derivative, you do have options. I'm going to do product rule. I've got this stuff times this stuff. In theory, though, if you want to cube this times itself 3 times, and then multiplying x minus 6, if you're willing to do all that distributing, again, you don't get to just cube this and cube this. I think that sounds like more work, but that is an option, I guess. So, product rule says take the derivative of the first, which would be power rule and chain rule, times the second left alone, plus the derivative of the first times the second left alone. So that's not very clean, but it is the derivative. Oh. I wanted to share the scoring with you as well, but I don't have it pulled up. I can't find my handout, so I'll share it with you with it at the end. I think you got 1 point just for having the derivative correct, though. And then I believe critical numbers are when the first derivative is 0 or undefined. This is never going to be undefined because we don't have x's in the denominator. But it does equal 0 sometimes, so I'm going to try to clean this up a little bit. We've got a 3 times a 2, an x minus 6, and a 2x plus 4 squared. And over here we've got a 2x plus 4 cubed. I think you even get a point just for setting it equal to 0 as well. But to get the last point here, you have to finish solving these for these critical numbers. And we're going to need those for parts B and C as well. Okay, guys, you'll need to hold off on whatever you're working on. Okay, now why I think this one is harder than 2 and 3 is the solving of this. This is no calculator, so you can't just graph this and look for x-intercepts. You've got to think of something else. And I've mentioned this in the past, but I think this is honestly got to be top 3 easiest algebra things you've ever learned, but you guys often don't see it. So, any ideas on how to move forward here? What do you think? What was the first part of what you said? Okay. This and this have a GCF, So you can and should factor it out. What they have in common is a 2x plus 4 squared. So this times this is supposed to give me this. So it leaves behind a 6x minus 6. I'm just going to distribute that. And then this distributed to the second thing needs to give me this. So it's already got 2 of them. It needs 1 more. So it needs 1 more 2x plus 4. Now that we've got factors, something times something, we can set each one of these equal to 0 and solve. And so this should give us -2 and +4, I believe. Is that correct?
Mm-hmm.
Yeah, what you got?
Would it be helpful to take 16 out as well?
16?
Yeah, like 8 out and 2 out.
Well, you can't factor 2 out of this, if that's what you're thinking, because this stuff is being squared.
Okay.
So pulling a 2 out of that would be incorrect. You're welcome to pull an 8 out of this, but I don't know this any better, so I don't think it would have made the algebra much easier for you. So that's optional. Okay, part B. For what values is G increasing? So if I want to know when it's increasing, am I thinking about function, first derivative, or second derivative? First derivative. Which, good news, I've already got it. So if you missed that, then that could domino and mess you up on other stuff. And specifically, if these two were critical numbers, these would be the 2 locations the graph might be changing directions. I know it's not changing directions at x equals 3, so if I can figure out if it's increasing or decreasing at x equals 3, I know it's going to be increasing or decreasing the whole time between 2 and 4. So I'm going to plug 3 into the first derivative and figure out if it's positive or negative. So notice, I have the first derivative here. You could plug 3 into this, but to me that looks scary. What you got?
We're from student council and we were collecting canned food. Do you have any by chance?
I don't have any.
Okay, thank you. Sorry for this.
No, you're fine.
Mr. Townsend, would it be -2?
Oh, this would be -2, yes, thank you. Okay, but 3 is still a good test point. But notice, this is the derivative. Also, this is the derivative rewritten. This is the derivative with the GCF factored out. This is the derivative with the GCF factored out and combined like terms. You can plug this 3 into any of these. They're all supposed to be the first derivative. To me, I'd probably plug it into this last one because it's a little bit easier. Plugging in 3 here, this stuff becomes positive. This stuff becomes negative, and a positive times a negative is negative. Okay, it might be changing directions at 4, so I'm going to test 5. So same thing, plugging in 5 here gives me a positive, plugging in 5 here gives me a positive times a positive is positive, and then maybe test -3. Always positive because it's squared. Plugging in -3 here gives me something negative. So that's decreasing. Now, I don't know that I've seen many of your questions like this, many of your sign charts, but just from past experience, you guys need to make sure you're not taking shortcuts here. The numbers that are your don't just throw numbers here. -3, -2, 3, 4, 5. That tells the person looking at it nothing. Tell me that you think -2 and 4 are critical numbers. Tell me that you plugged 5 into the first derivative and think it's positive. Tell me that you plugged 3 into the first derivative and you think it's negative. There's no justification on why I think this is going down if you don't write even that. And then sometimes y'all even do this. And that doesn't mean anything. You think it's going down at 3, but why? You're missing all the justification. So, and a lot of times that is not needed, but when it is needed, it's good to have. So it's just better to make a habit out of trying to put all that stuff there. Okay, I did all of that for what? I want to know when it's increasing, so looks like 4 to infinity. 4 to infinity is when it's increasing, and justify my answer. How did I know it was increasing after x equals 4? Because the first derivative is positive. Now, somebody yesterday said because the first derivative at 5 is positive. That would not be a good justification, because even though first derivative is positive at 5, you've opened up a new can of problems. What about 4.5? How do you know it's increasing at 4.5? What about 4.1? Why didn't you list those? So simply saying during this time the first derivative is positive, this is what they're looking for. But sometimes this is good too. Just wasn't necessary in this question. Okay, also with this sign chart though, which of the critical points have a relative minimum? So we can just glance at our little sign chart and see that there's a minimum at x equals 4. Everybody okay with that? Okay, but what about the justification? How do I know there's a minimum at x equals 4?
F prime is negative before and positive after.
F prime is negative before and positive after, and I just need a little bit more. Before and after what? Okay, so what's this? Before x equals 4, and this after x equals 4. That's plenty justification. And I have the work to back it up when it's needed. Okay, I need to slide over to my other classes to show you the point values because I couldn't find my page, but they asked for the same one. So just to show you how the 9 points were distributed here. I was wrong. Part A, you actually get 2 points if you did the product rule correctly. No simplification needed to get these 2 points. 1 point if you set it equal to 0. So even if you looked at that, could visualize setting it equal to 0, and could do the algebra and get the critical numbers correct, they want you to show that. The whole point of an FRQ is for you to show your reasoning and your justification. If they just wanted to know the answer, it would be multiple choice. But 2 points for the derivative, 1 point for setting it equal to 0, 1 point for getting this critical number, 1 point for getting that critical number. 5 points for part A. Part B, there was 1 point for 4 to infinity, 1 point for the justification. Part C, 1 point for x equals 4, and 1 point for the justification. Justification is usually half the points, or almost half the points. And it's not that the justification is difficult, but if it's not the way that you would just naturally want to justify that, then you kind of have to retrain yourself. This is very efficient. It's what you want to be aiming for. Okay, any questions about this FRQ1 before I move on from it? Okay, then next up, if I promised that I would let you ask 1 or 2 more questions from this circuit before I had you turn it in, because there was a couple that were not on the website as videos. I already let you ask questions from these, so you may not have any others, but we need to split in 2 ways here. If you still have 1 more question to finish up this circuit, tell me which one it is so I can help you. And if you're finished with it, go ahead and start working on your last FRQ on the page we just were looking at. Yes.
Could you do the last question on the first page? It should be number 14.
Last question on the first page. This one?
Yes, sir.
You said it's 14?
Yes, sir.
Okay. Okay, you guys need to see if 14 was one that you needed help with before you work on something else. Alright, so they want us to know when this is increasing. So even with 0 work here, I know that this is going to have something to do with the first derivative, and my answers are going to come when the first derivative is positive. So that is my hint that I'm going to need to take the first derivative. So you could either rewrite this, do power rule and chain rule, or you can do quotient rule if you'd rather. Whichever one you think is easier. But I would say that would be the first derivative. To know where it's increasing, we need to test around critical numbers. And critical numbers can be when the first derivative is 0, or undefined. And I could take the square root here, add 9, take the square root. What numbers make the denominator 0? Good. So I wanted to make sure that you got both of those and not just one of them. When you take this square root of both sides, you need plus or minus. That's why it's plus or minus 3. So like on that FRQ we were just talking about, notice how I'm labeling, not just throwing these on the number line. I'm saying I think these are critical numbers. And that's helpful because what if you can't finish this question, like you get stuck on it on a test, and you have to come back to it. It's nice if you have some of this labeled so you remember what your thought process. But we can test and see what's going on at 1, whether he's increasing or decreasing. So plugging 1 into the first derivative, notice the denominator is always positive because it's squared, but plugging in 1 makes the numerator negative. Negative over positive is negative, so decreasing. Maybe test and see what's going on at x equals 4. We would have negative over positive, which would be negative. Maybe test at negative 1. That would be positive over positive, which is positive. And it could be changing directions here because this is a critical number. So we've got one more to test, maybe negative 4. That would be a positive over a positive, which would be positive. Okay, now I don't know if this is why you asked this question, but this is good for everybody to, unless you are sure what I'm about to say, why the final answer is what it is, this is an important topic here. When is this increasing? Do you see how it looks like it's increasing this whole time? From negative infinity to 0? Does that make sense? That's not the answer though. It's not increasing from negative infinity to 0. It's increasing from negative infinity to negative 3. At negative 3, the derivative's not positive, it's 0. It's horizontal for a moment. So you can't say that it's increasing at negative 3. Then it increases from negative 3 to 0. But it's not increasing at negative 3, so it should not be part of your interval. Is that why you asked that question? Yeah. That's a good one to ask because that's very easy to overlook. Looks like it's going up the whole time, but it's really not going up at x equals negative 3, so it shouldn't be part of your increasing interval. Okay, you guys were quick with that one, so I can take one more if there's anything else still on this one. Okay, so I don't know, to me that circuit is really more review anyway. But there's two things you need to have finished up so that you can turn in. That would be 54 and 56. So 54 was that circuit I just gave you a second chance to ask questions on. 56 are the practice FRQs we started class with. So you probably have one more of those to finish up. Both of those need to be turned into Google Classroom before Monday. So probably just turn them in as you finished them. And then the bulk of your class time today should be on starting your test review. That's the 2 handouts you guys picked up. And it is structured similar to how your last test reviews have been. It gives a topic like mean value theorem. Make sure you know what things you have to have memorized about it, and then a few practice questions to give you some feedback on if you know it well enough or not. Then it does another topic. Make sure you know what you need to memorize about it, and then a question or two to practice. First derivative test, do you have the memorization stuff memorized, and then try a couple practice questions. So it's formatted all that way. The back page is like one ginormous FRQ. So practically anything we could ask about a first derivative graph, but honestly, if you know how to read that, that's actually not too time consuming. I can work that whole back page in probably 4 minutes. So if it takes you much longer, then at least you're realizing what it is that you're not up to speed with. So that's the plan for the rest of class. Finish up circuit. If it's not, finish the last FRQ, so 56 is finished. Turn those 2 in the Google Classroom, and then get as much done on your test review as you can. Our test is not next class, Monday, but the class after that. You guys have seen all the big stuff. You've been practicing on trying to get all of that information sorted in your head, but to get to where we need to be for Thanksgiving break, we need to test on this on Wednesday. One other thing to keep in mind too is the next section, we only spend like 2 days on it and then test, because it's like all the same stuff. It's called curve sketching. So given a function, we're going to ask you to graph a function very accurately, but if you know when it's increasing and decreasing and when it's concave up and concave down, all you really need to do is get a couple points. So I'm only pointing that out because knowing this stuff really well for your next test will make the one after that seem easy in comparison. Okay, I'm going to come around and help. Just call me over. Except on mean value theorem, we don't need to.
Yeah, I know the square.
So don't include 0. Don't include mean value theorem is trying to show you that the instantaneous rate of change is equal to the average. But at the endpoint, it doesn't really have an instantaneous rate of change because there's nothing to the left.
If you were to do this, you would have
Yes, so you need
x
to
to
do
the
the
fourth, so
slope
then have them put x, so you do x to the fourth.
y1 minus.
No, I'm saying when you solve it,
And that's why you
0,
that's why you split it up. So
the
x is equal to 6, y is minus 1.
value for
Yeah, this will be the final. That's why I got it.
Oh, we have
your next thing.
Yeah, I was trying to. It was hard. That took me a little bit. What is? I just really didn't get good at grouping.
Mean value theorem
haven't
is
been
defined
able to do
on
it like
the biggest or smallest values. Max value is running value.
So we find
So
that
just make a table, test the critical numbers and the endpoints,
It's like you multiply.
and then your max value will be a number.
And you find like factors or something like that.
I just didn't know how to
Multiply. I don't.
I just didn't know how to group those two before the
Yeah, like your critical number you plug in here.
Okay, yeah, that makes sense.
Okay, that's what I told them, but I didn't.
Because if you're plugging into the derivative, you're figuring out how fast it's going up or down. That doesn't tell you anything about the
I
value.
just forget it.
Like,
I don't know how to. I keep.
Like, yeah, that, like, for instance, they need to group it, you can't just like see the factor. I'm not.
Do you know Cambridge?
Sometimes I don't know it. I just lazy. I need to.
What do you do?
I just need to
Did you get any free stuff out like in the
division. I need to review that. I've already asked that. Yeah, like today. It's pretty sick.
If I see you, I'll give you. It's like not that good. I'm just saying. Or if I ever see your mom. Yes.
No.
Are you seeing that video? I think so. Last video I watched it. Zero. And then like something different than what you did. If you don't see why I really found out to find that. Sorry for me to lie. If you just do, just do this.
Bro, I don't know. It's still gonna be. I'm still gonna give you.
I like your notes.
What the heck did you do?
Just added the 4x.
That was, that's a tough one. So there's the derivative.
It doesn't work.
Okay.
Because
See how the x equals 1? The derivative is 3.
the one is negative 2.
Because derivative is slope. The slope of this is 3.
From the derivative.
Look, it's because of this?
Yeah, no, I'm not saying it's what's the slope of this?
That's it.
Okay. Slope is the same thing as derivative. So at x equals 1, the derivative is 3.
By -1 and then 0 stays 0.
Correct. But the slope of a tangent line comes from a derivative.
No, I don't
You
think so.
should set the derivative, which you've already thought about, equal to 3.
But
And then
if you
plug
do
in 1 for
negative 1,
x.
but
And that lets
take
you
the
solve for
negative out,
a.
then negative 1 times 0 is still 0. I mean, that'd be fine. That'd be good.
Yeah. What times 2 can you take the sign of this?
I want it to pure complicated. Yeah, because like it's almost
It says not done. Number 2. Can you turn sine of 2x into sine of x by factoring? In the beginning, for the derivative.
No, but you'll get down to sine of 2x by the end of it. So this like when you're I mean by the end of the it's
The top. So you didn't have the quotient of the.
That's what I did.
Oh, here's
X.
Oh, that makes sense.
this is
Oh,
X.
Sounds like easier, like.
times 2 gives you the pi and sine of pi.
Thank you.
Can you do that?
Just divide the length by 4.
Have you looked at the website?
No, I had no idea. I did that.
Instead of just doing it over the entire number, it's over 1 and over 4. No, it's that's just
So how's it working yet?
I don't get why though.
Wait, what? Why is it the maximum value? Isn't that just the critical number?
Play it out loud a bit.
Oh, that's because that one is value.
Hold on. They were working this question a second ago, and I think they got
So
equal to 0.
this one is.
Well, I'm not saying you're wrong.
One
I'm
that's
just saying
saying the
that
X.
they might be wrong.
And then 0 and pi came from. Yeah. So then all of those can be complementary.
Okay. I think you're.
I'm gonna do what you do.
Okay. So what I would have asked you to do in pre-cal is just ignore the 2x for a second. When does sine equal 1? Okay. But yours isn't really x, yours is 2x, right? So you didn't really solve for x, you solved for 2x. So I want to divide this by 2, so to keep the balance, divide this by 2. Pi over 4 would be the solution to that equation.
Does this make sense? 2 pi plus 1? How many groups? Is there any way to put those together?
The sine is 0.
2 pi and 1 are not like terms. When you check your answer, you're going to see that's 1 point. Like they're expecting you to find that value. That's correct.
But you can't even imaginary number on that number line. You just put 0. What if we just do 0?
That would equal
Is sine of
satisfied.
0?
So where's your mean value?
That is 0 is 0. Okay, that might work. Just do the number line, but with
Just imaginary numbers.
or but just with 0. Because you can't put an imaginary number on that line.
Oh yeah.
Maybe there's a chance that 0 is the only time you can just
That's possible.
okay.
Well, you can combine those to just say plus 6. Then you're going to have plus the
maximum will be a 5.
well, you get to the tangent line is in the same place at the same time as the function, right? Tangent line touches the function. So you can set this equal to this when x equals 1.
The maximum body is 2 pi.
Like if this represents the function, this is the function, and then this is your tangent line when x is 1. You see how they're at the same place at the same time? So you can set the function that you know the equation to equal to the derivative, which you know the equation to. And plug in 1 for x, and plug in -1 for a, and then you'll have something that you can solve for b.
Really?
Yeah, it's skyrocketed.
We got it.
You're going to have to do it one step at a time.
We used it, yeah.
Do the first few steps and see where you get.
Super helpful.
So,
I bet you your grade went 2 points.
first of all, I don't like that it's starting to of the same value.
926.
Where did you get 2? You plug 0 into what? That's the derivative.
Oh,
You want values, so you need to be plugging into the function.
That's great.
I know.
Well, that's a great test score. Like, test score.
I'm happy about that.
It's probably good enough.
Oh, yeah.
Oh, shit.
I will also say that those of you working on the test review, I think the front page is the hardest. A couple of those mean value theorem questions are pretty tough, especially 4 and 6. So you might want to do 1 or 2 of those and then jump to a different skill and then jump around. You don't have to do every mean value theorem question before you move on.
For this, I got this for the derivative.
Yep.
And on here it says this, but that's the same if you just split it up in like.
Simplify.
So would they take that?
Mm-hmm.
They would?
Yep. FRQs, you don't have to do any simplifying at all.
Okay.
If it says something like f of 3, they expect you to replace that with a number, but.
Okay, yeah.
You shouldn't have any decimals. This is no.
I got 2 pi minus 1.
Okay, so only for answer 2 pi minus 1. I'm not saying that that's right because I don't know what the answer is. But they want you to do the exact same. When you check your answers online, you see that the answer they're looking for is like 2 pi plus 1.
18 out of 30.
That should be a decimal.
She gave me my points back because of my
For part A, this is called the candidates test. So if you're testing the critical numbers and the endpoints, that's all the justification. That's why. Well, you need to state what you think the answer is.
I don't know about your class.
You need to actually say this is but that table
But like a lot of people in that
is what's called the candidates test.
This doesn't work. The top doesn't work. My whole thing is that I was like, it's too much, it's hard. Like everything seems like, oh, that's not that bad.
That's
And then when
perfect.
you do it, it's like.
I think it's probably implied if you don't say it from 0 to 5, but it doesn't hurt to say that.
That's what I was saying.
I don't think that's right. Well, no, the secondary is concave up.
No, right, but like how's it the or well, it could be just one.
Do we plug these into the original?
I think it's about to draw a picture of how it can work.
Yeah.
You heard us say, how can it be a
How can it be
drive?
increasing the concave?
Increasing concave up. Increasing concave down.
Yeah. So then just wanna-
Decreasing concave up.
Okay.
Decreasing concave down. It could be both.
So never concave down.
Never. Not like no room for
Oh, no, it's just change
You're just changing direction. You never change direction. It's just 0.
Oh, it really doesn't change. I'm not joking. Are you serious? Yeah. Like, I'm reading. Oh, okay.
No, because F1 prime, it's like F prime is less than 0 and But Dr. Russo called me this type of. You don't know that? Okay,
I said equal to 0 too, just like add it off on reflection.
Oh, I thought you are. Yeah, I have a 13, which isn't passing, but that's way better than I thought. Okay, well you need 16 points to pass, but it's at the top. But no, everyone gets like a 13.
That's right.
I need to be better. I got 5 on reading and listening. So it's like surprising, and they're out of 6. And another 3 on writing, and a 0 on speaking. So I think I might pass them. It might be able to. And it's really non-bad. Well, okay, it's hard, but they grade it easy. Because like I didn't write anything on my writing, and I still got a 3. But I like, couldn't write anything.
Can you cancel
Oh
here? No, right?
No, not this part.
Yeah.
You can fast. You know you can.
Anything else?
Again, you hear me say some of those are a little hard. You might find it.
It's like where the
It's the body. It's a little bit of candy towards the end.
Yeah, I love Halloween.
Did you get a lot of candy?
You know what control formula was? So when you did this over here, that was the average value.
Okay.
I think it's
that's how I think.
yeah, like the star. Maybe 1 to 12. I don't know. Either 0 to 12 or 1 to 12. But then how they do that? I would do 0 to 12.
It was like,
That way, if your answer is like 0.8, you know what happens during the first one. But it's not like between the start and 1.
And like the derivative of that one.
No thanks. Okay. Can I help? Anything else?
Maybe one question on this. Do you think we got it right? We got like an imaginary number like this,
Okay.
and then we would just not use the line.
Sure. Because it's not going to show up on the graph.
Okay.
Eyes aren't going to.
So it is possible to get an imaginary number. Okay.
Yeah.
Okay.
You didn't check your answers though? Yeah, you need to check them online. And a big part of the FRQ practice is you need to see the justification, because like you might have gotten part C right, but you may not have said the justification they were expecting, and that's.
Oh, right. So this part.
If you're not learning from those mistakes, then those will never get easier, and you're going to think they're always impossible.
I can pull it.
That's what the rest of the year.
Wait, you was here. Just a minute. Yeah, gosh.
Just got anything I can help with?
And then everywhere reflection from 2 is silver. I appreciate it. And then our reflection point is just 0.
Where does +2 come from?
Sorry. Plus 2 cosine of 2 pi. That's 1. That's 1. Then the 0 would be 0 plus cosine of 0, which is 1 as well. 5 plus 1 plus 1.
Why is it +1?
I don't know why.
I thought it was minus. I think the +1 and the -1 are going to cancel, and then your pi is going to cancel. So I think it just equals 2. And then it's going to be similar to this. Similar work to that one that you asked about a minute ago.
Yeah.
Is this when I use the EBT? Okay.
And the EBT just tells you to plug in the endpoints,
So
which you already know, 0 and pi, and the critical numbers, which you're going to have to go and find
It's like 2 over?
into a table. And the biggest y value is going to be the max, and the smallest y value is going to be the min. And you just want to keep the negative. If you want a value or a point, you need y. You actually have to solve that. That's the calculus.
Because half of x is always less.
It's like they set the same justification, but they got a different answer.
Yeah, it should be negative.
Yeah, they got
I don't remember the answer though. You might have to look at the AAC to see where you went different than the side. Yeah, that doesn't make sense. Your answer shouldn't be negative. Your answer should be between 0 and 12. That's not so wrong.
Oh yeah, we got.
That's why I said look at the answer, the solution, so you can see what step you
We got 3 wrong.
I mean, look at your answer and know what you did.
I mean,
Yeah.
Could be 0. Want this to here, 1 over. No, because then the way we raise it, that's my
Probably part calculator, part 1. When it's part calculator, part 1.
You change that.
2 of 1 times all of that.
We got 4 together.
Oh, I think I know. After they, like, we stopped here, they did was they split it. But we got the same answer, except they just simplified it.
But ours would still work.
Yeah.
Yeah, it's fine.
So then,
Why can't
what
you
is
use
0?
0? Yeah. I don't know why you can't use it. I don't.
Can you take the R?
It's not. It's not the limit.
As soon as they go.
You don't take the derivative of
Is there a reason that you have
bottom,
to
right?
and not 0 for this?
I forgot that 0 makes out lines of fixes, so we can't say.
Okay, yeah, so technically both of those make that true. 0 and pi make this true. But for mean value theorem, you're not supposed to include endpoints. Because if this is 0 to pi,
greater than or less than 0.
all you care about is 0 to pi, and you think this is one of the locations, well, mean value theorem is trying to show you where the average rate of change equals the instantaneous rate of change. But this can't be at the same instant because it doesn't even have the left side, and that's why you wouldn't use an endpoint. But yeah, 0 should be considered.
So we went and looked at the answers, and like, we understand how their first derivative was pronounced. They split it up and took out x squared from.
Yep, that's fine. They split apart their fractions of plus. So here's the equivalent, that's fine.
Yeah, that worked, and then we got the chance to B. And then our derivative was for C was like a good bit different, and we don't really understand like how they would get x cubed in the bottom, because like anytime we do it, like even for them, they would have like x squared right there, and then on the bottom like do the x4 I think I did is correct. I like when I drive theirs, it looks like it's
I'm with you here. This here. Wait. Where did X go?
We're gonna work every other.
What happened?
Oh, it's 8 times x squared.
I thought that was plus.
Then it's right there.
Okay, so right here, when you distribute this, you get a positive 8x cubed.
Right there.
And then you distribute it to this.
Oh, I totally forgot about that one.
And you left it at 1.
Okay, that would do it.
Oh, that's how we got
Yeah.
Yeah, because these two should cancel. 8x cubed and the minus 6 should cancel.
Okay, yep, I see it.
I put it high over too, because I saw it. I do.
Plus 2.
Maybe this question could see like value there. I got the slope. Actually, the years coming in the earth.
I can help with.
And now, so the
slope is positive.
Yeah, maybe it's got maybe it's below us.
I figured it out.
Yeah.
Oh,
yeah. It says change the look of yes, this is 0.
Are you looking at the form right now, sir?
The only thing that's confusing me a little bit is it looks like you're plugging numbers into the second derivative. Yes. But then your right line is increasing your derivative, which would be first. Well, assuming that this is positive, I guess it would be when the second derivative is positive, that doesn't tell you the same thing because it's constant.
But at least you would still get the
You should go. I don't see anything wrong with it.
Last time I pulled up, that's all I knew. That's all I knew.
I feel like I'm dying.
You've got to solve it. Oh, yeah, okay.
You're dying, but you'll wake up.
I just can't like breathe in.
Yeah, me too. Oh, Python A.
If it hurts, you need to go.
It's a pretty smart. But
I'll leave it at you on how much hurts.
We'll see. If I like can't breathe out.
No. Struggle a lot. Don't wait till you get 30.
Yeah.
I'm scared.
overall,
I just
what's your plan for the weekend? I already got a plan for you, actually. I've got your whole weekend planned.
I'm going to meditate and try to get you to do your homework. Hey.
I don't know if that's gonna work. Oh, you said you were gonna. You should go to the game tonight because it's my friend's senior outing. You don't know, but that's okay.
I think I will pass, but thank you.
But it's America speaking. Like you gotta come all out. Get white shirts. I've already got my white and blue. I am the stars right now. wish I had like those two heads for fifth grade. It's like soft. If you think of like khakis, it's think of
And that is my work too. Like that, I just need this time to sort out my thoughts.
yes. She's
Like I can't go every time I'm just like, ready to fit.
I've always been more the first
Yeah. Well, I do know. That's what I think too. Like I tell my mom, oh, we're doing like 6 of us, but it's like this split. I'm not anymore. This is getting she knows you just because the person that works there.
16.
There's always one story I go back to. Yeah,
That's the same day, isn't it?
I don't use Manchester though. I would say she doesn't like tracks. Yeah, you got these 40. Everyone starts somewhere.
Wait. Peppermint too. Oh. Serious. I like related.
These are all like really good.
work is so messy.
Oh, I signed up for the chapter for charity.
See, why don't you like
I just heard that something. Because I wasn't going to buzz my hair this year since, you know, like,
That's exactly what
meeting new people.
Like that's like fun. When Spencer comes here, I always have to try something.
My hair would be way more than $300.
You should do it. Yeah, they're paying for it.
Oh yeah, I forgot.
It's for charity.
Oh.
When you make 100, you get a circle sticker.
Oh, that's what I thought. That's why I was like, what is that? And he was like,
You said not like I'm gonna try to get baseball captain.
I mean, you get
Okay, Pierce.
Oh, yeah.
Wait, next year, Pierce.
Do you take anything?
Yeah, I don't know.
Are we doing anything else for your
You gotta take
class?
That's because you know
Like, there's no like
because you won't let me go.
severe side effects. I'll pass all these.
I don't want to. What if somebody has to go down?
I have a bad memory. Well, that's pre-workout.
I'm busy on
Like, that's also
No, I'm busy on every Saturday.
probably. Well, you have a great on the last test.
Oh, wait, hold on. I have it. Okay, wait, what? Yeah, I only was able to do it because I had the time for like stuff
It's missing part of the question. It should have the balance on there. Yes, now I'll have to look up what it's supposed to be. I knew there was something missing on that one.
like let's say the answer is here, which are 2 related. So like, okay, like, I must be doing something with that. So I just pick it.
Oh, like, so your homework?
You did. You said the whole I was excited. So you pick me over here. For me, like, what do you do with the game? What am I watching? Just
It's like something small. It's like something small. You don't have to put something small. You agree something.
No, it's the one, remember, we had to do the option value. There was like, yeah, that's the one. So what is the list? I was saying, like, scrap it.
So for this one?
On the test review, question number 9 does not work without knowing the bounds. The bounds are supposed to be 1 to 5. It's just not printed on there.
What is that?
Bounds. We're not interested in that entire function. We're only interested in 1 to 5.
Decreasing here, but it's not cascading down. Because in this little corner. We knew that.
I knew that.
We did it. Finally.
All the way up for Jack and a tie. Because they're like, what was the last one?
I got, no, I got.
Okay.
Okay, so I did.
Yeah, you got 9.
I don't think I did. Thank you very much.
Is this part of 3 just asking find the values of x for which f of x does not exist? Is that just asking for the critical numbers?
No, because critical numbers are where it's 0 and does not exist.
So just find x in?
Where?
Find 0?
0 is the only answer. Any number that makes the denominator 0 is an
No, it's not.
This is.
I don't know how. I don't see such error.
You can still make it up. Other solutions.
I'd rather comp than take a comp.
Yeah, she's super nice. And you just had a baby.
Oh my gosh, that's what it is.
I'm just taking a break. Yeah, I'll be back. Don't worry.
No, 41% is generally crazy.
You don't have to
It has a case on it.
I used to say that too. On my phone, crap.
13 weeks.
I think you have to try to lie.
Not when it cracks.
Avoid work and not go to school.
You deserve that.
I like the phones are so much nicer though without the case.
Wait, 9 is.
That's fine. I've had this one for like 4 years.
What first one is
No, that's right. We also like have SD card flies.
Then I'm giving you more. I got an 80 million class. Just one time that someone checked it out. No. It was like, oh, I saw it. It was out of hospital. No, I was like, there's the Dixon.
Can you have imaginary
Yeah, that's what we got to do.
You just don't put them on the side chart. You just don't put them on the side chart.
Did you guys query? Yeah, we got the same thing. I can see it. It's going to be
I'm confuzzled on number 9. So I found the solution being negative infinity to 0 since...
That's not the derivative. You have to do product rule. X squared times e to the x. You don't get to just take the derivative of x squared and then the derivative of e to the x. If that worked that way, we wouldn't have a product rule. Christian, you need to get back on task here.
Do what?
You need to get back on task.
Oh, yeah, you're right.
I just know because some of them are bad. Like some of them don't make sense that I didn't try. This is right here, so. No, this is like what I'm
I just feel like you're being a bit sketchy. I wouldn't say that. I think I put down honor society and I mean, we did the first. It was fun. I'm not gonna go. Like, it's not work.
Oh, no, I don't
No, it's fine. I'll ask you about That's incredible. Just like flip the looking forward to Mr. Townsend, I have one last question and I'm almost done. Like after you answer this one, I'm done.
If it's not math related, you shouldn't be asking right now.
No, it's math related.
Okay.
I swear.
Okay.
What do I do with this too? Oh, he has my paper. Oh, okay.
I like walking in that.
I'm trying to follow along with this. And I got 2 out of this.
Okay.
But I don't know what it's asking for this.
Okay, so this is the average rate of change. Executed all that. Mean value theorem has some derivative.
It's like I don't take the gold that I use back into anything now that
Derivative
I don't have any more soy for.
You got the derivatives up there.
Yeah, right.
Was there what else that you do equal to that and solve?
Wait,
So 2 minus something.
Yes, your derivative, which I think you have right here, is equal to the average rate of change, which is right there. Mean value theorem guarantees that that has to be true.
Minus 2, that's going to be negative 7.
Oh yeah,
That way you know what you're doing.
went from going downwards, then to
Like every
that meant maybe
kind of confused on the relation between these two graphs. Like it had a negative slope went into 0.
Mm-hmm.
And then here it says that it was concave down before 0.
Okay.
So wouldn't it have to be like a positive slope prior to?
Positive to be why? Concave down?
Yeah.
You can have increasing that's concave up. You can have decreasing that's concave up. You could have increasing. This is concave down, sorry. Decreasing can be concave down.
Concave up.
Concave. Okay, so here's the two ups, whether it's increasing or decreasing. And whether it's increasing or decreasing, you can have concave downs as well. In fact, there's really, I mean, we don't need to be doing this to get an answer, but we can just look at the graph and see. Is it this one?
Yeah.
Decreasing but concave down. Decreasing but concave up. So your work looks fine. This doesn't tell you exactly what the graph looks like, but it does tell you when it's decreasing and when it's concave up, concave down.
What different squares is it?
Oh, that's already like
You have to do the thing.
That's why we shouldn't do that. I don't know how to do it.
He said it was just like a diaphragm, sprats.
It's still good to know, though.
Yeah. You do the 2 times 6. And then you make it 4 things.
Alright, that gets it back.
And then he gave me electrolytes. I know you're like super worried back here.
And then
Oh yeah.
It's a little bit easier after the first one.
I'm sure you did.
Yeah, I did.
I believe
Something. But you can just divide that into the edge. You can't divide that very easily.
Yeah, I'm not excited to start.
Like, what's the number?
Oh yeah, and it's not like.
What's the number that's the same as itself squared? There's a number that's the same as itself squared. No. Orange.
Oh, why? I'm struggling.
On number 2?
Yeah. What, you got a problem with that?
So it's 2 cents over the multiplier. If you divide both sides by math, what math? When you divide by a variable, you're probably losing the answer. So instead of dividing out that e to the x, you need to factor out. There should be a multiple you had an e to the x, you could factor it out.
Have you ever gotten super mad at us and try to look through it?
I remember when you were explaining.
You'll get mad at what's your sign? It is, yeah. It is. So it's pretty cool. Yeah, I finally did it. When you like always do it. Once you realize that that's why we most like high
Distracting.
It's all in good form.
You're good. Great, you're second. I did 3. Like, I want to see it on like what situations you would be upset in.
That would make that on hold, whatever that is.
That would make me sad. Mirror or something.
Oh my god. Yeah. Yeah. Not to the line though, but.
I don't think you have to do that though, to me, so it's all right.
Literally nothing. Nothing. Yeah, it's the only place to be like.
There's like a chocolate place away. Talk to John.
Nope. That's only talking about that. I don't know. He lives in my neighborhood.
Nine is on the website, but it hasn't videos.
Well, I told Bo, you know Bo?
Now you're on your own.
Guess what I did?
And then I told him, because he's like, you have the outlaw, I'm like, everyone in my neighborhood is school.
Is that what
And then we were trying to watch, just helping. I said,
I'll put the speakerphone.
You don't need to have it finished by next class, but it costs us the last class. So
he goes to that.
that will be on there.
I feel hard right there.
We don't give like practice.
Wait, didn't you just tell us that I was by you actual practice?
Yes.
So, there we go.
Your issues like started in prayer. Yeah, when you have like 4 years.
I thought it was kind of where are you thinking of like
You could do like Google search or do multiple choice questions, and do like first derivative increase and decrease. And then probably do first couple of probably show you some like like something you find or
yeah.
the problem is on our AP, they always change the questions or give information differently or present it in a different way.
I'm definitely not nervous.
This question, that's not going to be on the test. So what you do
Yeah. Why is it she even going?
What?
She hasn't been going.
She's in band too. Yeah. So then, and then band's like practice. Yeah, every morning, basically, every night, basically. And then like they've had 2 or 3 competitions recently. So yep.
Alright guys, we're down to 5 minutes, so I need to remind you of a couple things before we pack up. First up, I need you to turn in 2 assignments in the Google Classroom. That was the practice FRQs number 56 and the circuit number 54. How much of your test review you get done is up to you, but I would say it should be proportional to how prepared you are for the test. If you feel like you are not ready for the test, you should do more of the test review. If you feel like you're ready for the test, you can probably get by with a little bit less. But next class is your last opportunity to get help, so the more of the review you get done, the better.
You realize they made us, they like let us do stuff with the marching band.